Okay, in this question they have provided a pentagonal pyramid. Pentagonal pyramid represents a pentagon has how many sides? It has 5 sides. So they have provided the condition as pyramid. A pyramid means it has a base on like a pentagon, but on the top all the points will meet on a single point where it is considered to be the apex. So they have provided the base as 30 mm and the axis as 60 mm. Then followed by, that means the base of your pyramid is 30, then the apex is 60. So for your reference I will show over here. So base of your pyramid, that is your pentagon, will looks like this. Then they have provided the length of the pentagon as a pyramid condition is 60 mm. So your pyramid condition is like this. Okay, so they are telling, for your reference, first we can develop a small rough draft. For that I am showing you. They are telling 30 mm and 60 mm, then followed by rest with its base on HP and the edge of its base is parallel to VP. The edge of it, okay, the edge of it is parallel to VP. Then they are telling a sectional plane perpendicular to VP and inclined to 45 degree to HP passes through the axis at a point 35 mm. So from the base you are going to consider, see here, axis at a point above the base. So this is your base. So this is your base. So from this base they are telling 35 mm above. That means if you consider the axis, maybe this is your 35 mm. On this point they are telling it is cutting inclined at 45 degree. So when you keep your protractor at this point, where will be your 45 degree? You can able to find your 45 degree over here. Okay, you are going to consider, that means you are going to cut from this point. Okay, if you cut from this point, how your top view looks like, then see here they have asked you to draw the sectional top view and what the true shape looks like. You will develop a true shape over here. So this is the question outline. You are going to develop this in a paragraph. So this is the outline of this question. Now we are going to develop the condition. Okay, first we will develop our xy plane. For developing the xy plane, I am going to consider over here. Okay, I'm going to consider this is my xy plane. Okay, so I'm going to consider this as x and this as y. Then followed by, I'm going to represent this as my VP and this as my HP. So this is the important one. Whenever we start our drawing, we want to mark this one first. Then followed by, we will start the drawing. So over here they clearly provide a pentagonal pyramid of base 30 mm. So when you consider a 30 mm, you can take your stencils. In that itself it has 30 mm. Then they have provided in this question that the edge, okay, the edge of its base is parallel to VP. So I am going to consider So this is my pentagon. So I am going to mark my dimension of this pentagon as from this point to from this point to this point as the base of 30 the base of 30 mm over here. Okay, so when I mark this one, I can able to understand the base is 30 mm. Then followed by I am going to develop my reference over here. Okay, for developing the reference, we have to consider a green line. That means I am going to develop my reference from these points. So this is my first reference point, this is my second reference point, this is my third reference point, then this is my fourth reference point, and this is my fifth reference point. Okay, so all these are my reference points. So now we are going to develop our front view. For developing the front view, I am going to consider it. They have clearly provided that it is 60 mm. Now what I am going to do is that first I am going to develop my base point. So this is my, wait, I can take my compass and mark as 50 mm. First I am going to consider, okay, this as my 60 mm point, this as my 60 mm. So I am going to place it over here, and I am going to, yes, yes. எப்படி வரும்? வெயிட் பண்ணுங்க. அதாவது இது வந்து இப்படி வரும்ன்றீங்க, கரெக்டா? இஸ் தட் ரைட்? இஸ் தட் ரைட்? ஓகேவா? திஸ் ஒன் இஸ் ஓகே. நவ் இஸ் தட் ரைட்? What they have represented now? A sectional plane perpendicular VP and inclined to 45 degree of HP through the axis. Then on the top rest with its base on the HP, and the edge of its base is parallel to VP. Is that right now? Okay. Now consider the reference points. Okay. Then take your compass, keep it over here, and cut an arc. Now consider your develop your cone over here from this point to here, then on the base condition. Okay, you have developed your cone. So in this cone they are telling that a sectional plane perpendicular to VP and inclined to 45 degree to HP passes through the axis at a point of 35. So over here the length we have considered as 60. So we are going to consider a 35 degree over here. Okay, cut an arc, then take your protractor, Now they have provided 45 degree. This is your 45 degree point and this is your reference point. Now consider a cutting plane from this point to this point alone. Okay, so this is your cutting plane. So when you consider the cutting plane, you want to represent your cutting plane reference from this point, to here, then point to here, from this cutting point to here, then over here you cannot able to find any cutting point, so it is on above your condition. So you want to consider the intersection of this point. Okay, then followed by we can start our notation marking. So when you consider this condition, this is your true position, that is from this point to this point, or this point to this point, then from here to here, then from here to here, then last one is from here to here. So this is your true position. So you are going to remove the above position, that is you after above your section plane, whatever is that, it is removed. So you want to mark the true position over here. So I am going to start my notations. So I am going to start this as A. This is my point A and this is my point B over here. Then this is my point C. Then this is my point D and this is my point E. Okay, then followed by over here marking as A dash over here, then B dash over here, that is on this point, then E dash on this point, and the last is D dash and E dash, D dash and C dash, D dash over here and C dash over here. Okay, so now what shall we do is that we can start marking the cutting plane conditions also, that is 1 dash on this point, then 2 dash on this point, then 3 dash on this point, then 4 dash on this point, and 5 dash over here, then 6 dash over here, then 7 dash on this side, and 8 dash over here. Okay, so we can mark our section points over here and you can represent this as V point and this as T, and we can mark the dimension. So for that we can consider from this point, that is on the top of your system, and from these two conditions we can mark our dimension. For marking the dimension from the top, what is the dimension of it, then from the cutting plane what is the dimension. For this The top is having 60, so 60 mm of dimension. Then another one is having 35 mm of dimension over here. Okay, then followed by the side of your base from this point to this point. The dimension is how much? 30. The base is having 30. So this is your marking. Now we want to show how our section looks like over here. Okay, for this we can consider our plane, a reference plane first over here. Then we consider that as a parallel one. On this one we are marking this as x1, x1 and y1, x1 and y1. Okay, now how we can develop our sectional view over here? How we will develop our sectional view over here? Anyone? Anyone can say how we can develop the sectional view on the top side? 1 dash 2. Then 2 dash 2 and so on, sir. mm, okay, where you can able to find, wait, I will tell you. So when you consider your 1 dash and 8 dash, where you can able to find, it will be over here. Okay, then followed by 2 dash and 7 dash, the point will be over here. Then 3 dash 6 dash, it will intersect over here. Then 4 dash 5 dash, it will intersect over here. Then this point, then this point, then followed by the 2 points over here, and the last one you can able to find, it will intersect over here. It will not touch here. I will zoom and show you, where you can able to find this part is not removed. This part you want to show that part over here. So when you consider the true shape, I first draw the true shape of your diagram. It starts from here and ends here. Then from this point to this point, then from this point to here, then from this point to here, then from this point to here. That means the base where you can able to find this point to this point is visible. So I have shown that point. Then I want to show where is my cut section is. For that cut section, I will show from this point to this point I have cutted. From this point to this point I have cutted. You can able to extend and see. Similarly, from here to here I have cutted. Then from this point to this point I have cutted. Sorry. Then from this point to this point I have cutted. From to here I have cutted. Please understand, in this a small portion is there, I have not cut it. I want to show that small position. Now I am going to do my hatching. So when you consider the okay, when you view this your pyramid from the top, you can able to view your cut section like this. That means this part is alone removed, that is the black line which is indicated over here, this part is removed. When you remove that part, your top view will be looks like this, where you can able to find this part is available, that is shown over here. Then this small part is available, that is represented over here. Okay, now you can mark the dimensions like 1 2 and 3 easily. So this is your first point, then this is your second point, then this is my third point, then this is my fourth point, then this is my fifth point, then this is my sixth point, sorry, over here sixth point, then this is my seventh point, and this is my eighth point over here. Okay, can you able to understand your cut sectional view of the top side? Can you able to understand that? Anyone have any doubt on this cut section now? Is that you can able to understand the cut section view of your pentagonal pyramid now? Any answer, or I want to repeat once again? Okay, so what we are going to do is that we consider the height of the pyramid as 60. So I take my compass, place in the middle of my base and cut an arc intersecting my points to create my pyramid. My pyramid outer surface is created. In your question, they have provided that a section plane perpendicular to VP and inclined 45 degree to HP passes through the axis at the point above the base, 35 mm above the base. So above the base means from here. So from here 35 mm I am taking the measurement and cut an arc. So when I cut the arc on the axis, which represents axis of the cone, which represents I am going to develop my cutting plane point. Okay, from this point only I am going to cut. So your inclination of cutting they have provided 45 degree. So I am taking my comp, that is my protractor, and keeping over here, measuring my 45 degree and developing my what sectional plane or cutting plane. Okay, after developing my cutting plane, I can able to understand that this top part is removed. That means above this, above your cone part, this small part is removed, and this blue part is available for my section. That means below my section I am having this part, this part alone removed. The top part of the cone is removed, the apex, then 1 dash 2 dash 3 dash 4 dash points are removed. So this blue line indication is the available part for me after my section plane is developed. Okay, are you clear until this cone section? Can you able to understand until this? Okay, now after this what I am going to do is I want to extend my points. Okay, for this what I am going to do is 1 dash 8 dash I am going to refer that when I extend my reference line from this point, I cannot be able to reference from take my reference from a dash, because you can able to find a small area is available. So I want to show that small area is not removed from my pyramid. So what I'm doing is that I'm taking a reference from 1 dash and extending it. When I extend my 1 dash and when it reaches my first point, that is below your AB, that I'm considering as 1. On the above it is 8 dash, so I'm writing as 8. Second one, from 2 I am extending my reference plane, and that is reference line, and I am touching my pentagon. This I am representing that as 2, because 2 dash I am considering this as 2. 7 dash I am considering this as 7. The next point, the axis point, I can able to find a line is extended where it touches my pentagon on other side. So on the above 3 dash, below 6 dash. So first point is 3 dash. So I marked as 3, and over here I marked as 6. The last point is 4 dash 5 dash. Beyond this I cannot able to cut because I have my material over here below. On the above there is no material, so I am representing 4 dash 5 dash over here, extending a reference line and touching my pentagon and marking this as 4 and this as 5. So I want to show that this part is available from my top view. So when it is available, I have shown this as in white color. Here also a small portion is available, I have shown in white color. The remaining part, that is 1, 3, 4, 5, 7, 8. This part is removed on my pyramid, that is hatched like this. Can you able to understand now? The removed part is hatched. Can you able to understand? The top view of the pyramid cut section now. After this, I am developing a reference plane. This reference plane is called x1, y1. I am developing this reference plane parallel to my cutting plane to develop how my true shape looks like. So I am going to develop my true shape over here. For that, I am going to start my reference point. This is my first cutting plane. Is that right? This is my first cutting plane. I am developing a perpendicular line over here. This is my second cutting point on my section plane. I am developing a reference plane over here. This is my third cutting plane on my axis, so I am developing a reference line over here. I am going to consider my fourth point or the 5 dash point. This is my last cutting point. I am going to develop my reference line over here. Then followed by, I am going to take my 1 dash 8 dash and keeping on my reference plane. You cannot measure on 1 dash 8 dash. You want to measure only from your reference plane because we have developed the reference plane over here. So I will start my dimension marking from here and considering at this point. Okay. Now keeping on my point on the XY plane and cutting an arc over here. Okay, I am going to cut my arc over here. Then followed by once again keeping on my reference plane at this point, and I am going to measure what is my 8th point measurement. Okay, then once again I am going to keep it on my XY plane and cut an arc over here. Okay, then I am going to take my second point. You can able to find this is your second line. The extension is over here, so keeping over here, then rotating it and measuring my length. Okay, then I am going to place it over here, rotate my compass and cut an arc over here. Then followed by once again keeping on my second point, rotating my compass and measuring my point over here. Okay, then I am going to keep it on my second position and rotate my compass and cut an arc over here. Okay, then followed by once again I am going to place it on my axis, rotate my compass and measure the distance from the axis, that is the axis line from my reference, and keeping it over here on the third point, rotating my compass and cutting the arc over here. Then followed by once again on the axis I am placing my compass and measuring my distance from this point and keep it over here and doing my arc cutting on this point. Then followed by once again keeping over here on my 5 dash line, then rotating my compass, measuring this distance, or I just take this distance and keep it over here on this point and measuring my distance and cutting my arc over here. Then followed by keeping over here, then rotating my compass, measuring the value, then once again keeping over here, over here and cut it like this. So we have completed our cutting parts. Now we can mark what are the cutting values are. So over here 1 dash is there, so I am going to consider this as 1, sorry, 1 dash, 1 dash of 1. Okay, this is my 1 dash of 1. Then followed by, this is my 8 dash of 1. This is my 8 dash of 1. Then followed by, this is my 2 dash of 1. Then this is my, sorry, this is my 3 dash of 1, and this is my 4 dash of 1, and this is my 5 dash of 1. This is my 6 dash of 1, and this is my 7 dash of 1. Okay, so now what I am going to do is that I am going to intersect all the points. So from here to here, then from this point to this point, then from this point to this point, then from here to here, then from this point to this point, then from this point to this point, then this point to this point, then intersecting both the points over here. Okay, so this is my view on my top side. I'm going to do the hatching over here. This is my true position of my pentagonal pyramid. Okay, so you can mark what are your information over here. So which is, this is the true shape of the section as per your to find data. This is the true position. Okay, then this is your front view. This is your front view, and this is your sectional top view. Okay, so anyone is having any doubt on this diagram? So this is the pentagonal pyramid cut section view, that is on the top. When we consider a 45 degree of cutting plane and the point from the base as 35 mm, it looks like this. So anyone is having any doubt on this question? Can anyone can explain how we can develop this one, or this cutting plane on the top view alone? If you are clear with this, then the entire diagram can be completed easily. When you do this type of problem like your pentagonal pyramid or an hexagonal pyramid, you can able to develop this part very easily. That is your true shape. But when you consider the cone type, it's somewhat difficult because you cannot be able to use a scale over here because it is a circular profile. So your circular profile can be represented only by means of a freehand sketching. When you do a freehand sketching, you want to take more care on your development of views on the top as well as in the true shape. But if you consider the pyramid, you can able to use your scale and pencil for creating your true shape and the sectional view in both the conditions. Okay,